everyone, just Mr. Tukin, and we're going to go a little review video or introduction video, depending on when you're watching it, for graphing linear equations. In regards to that, we want to talk or focus on three different types of lines. And just in case, we wanted to remind you that if you're looking at a horizontal line, we're talking about one of those lines that's going left and right, perfectly left and right. Okay? And vertical, up and down, up and down. We've got that perfectly up and down line. And if you're not going up and down exactly, if you're not going exactly left and right, then you are kind of just a diagonal line. All right, so those are the three types of lines, though we're just going to be focusing on horizontal and vertical lines. So there's a couple different ways you can teach equations of horizontal lines and vertical lines. I like to do kind of more of a common sense method. So we've got this line here that we're looking at, and we want to think about what is its equation. To understand what its equation is, here's what I usually tell students to do. Take a pen or something, take an equation of a horizontal line, and go ahead and draw some dots, draw some ordered pairs on that line. And you can pick anywhere. You can just kind of go anywhere on the horizontal line. It's always probably a good idea just to grab the crosshairs. So as you can see, I've kind of put some points, some ordered pairs on this line. And what I ask you to do is pause the video and try to state what these locations are. What are these ordered pairs? Give you a second to pause the video. All right, so hopefully you did pause the video. And if you're going through and you're labeling these, remember when we get an ordered pair, we're going to say the x value. So we went left 3 spots, that's a -3. And we went up 3 spots, so that's -3, 3. If I'm sitting over here, I'm right on the y-axis. So I didn't go left or right any, so I'm x is 0. I didn't go anywhere. And I went up to, well, 3. And I come over here, I went right 2 spots to get to here. I went right 2 spots and I went up 3. So that's going to be right 2, +2, and up 3. And we come over here and we've gone right 7 spots and we went up 3. So here's the cool thing. Look at this pattern that we have here and ask yourself, what never changes? On this line, what is never going to change? Some people may turn around and say 3, and you'd be right. No matter what, this value is always going to be 3. And the other thing I usually say is, what is not going to be 3? Well, in an ordered pair, you've got an x and a y, and it's the y that's always going to be 3. It's y is always going to equal 3. And that's actually how easy it is to get the equation of a horizontal line. As we move on, let's go to this next one, and let's just say, what's the equation of this line? And you can do the same thing. You can pause the video, you can grab a couple points. But you could do that every time, but let's think about what rule do we see? What is never going to change? Well, if you list these points, we're at -6, 1, and we're at 2, 1. And no matter if I put another point over here, that's at +6, 1. You know, once again, the pattern of this horizontal line is that the y is always going to equal 1. So when I said what rule do we have, what rule can we find? For a horizontal line, it's always going to equal, it's going to be the y value. It's just going to be that equation. It's going to be a y equal equation. So if you've got a horizontal line and it's asking for the equation, it's actually always going to be the y value. Let's tie that in and use that concept. That same idea is applied to vertical lines. When we're trying to get the equation of a vertical line, we can again just throw some points on here. I always like to grab the one that's on the x-axis. But if we throw some points on here and you pause the video and write out what these locations are. Hopefully you went ahead and paused, and we've got 6. Oh, I'm even messing up live here. We went right 4, right? We went to the right 4 spots, and then we went up 6. So this is 4, 6 here. We went right 4 spots, and we didn't go up or down at all. So that's no movement on the y-axis. That's a 0. And finally, we still went right 4 spots, and we went down 5. So again, similar, think about it. Think about the pattern here. What never changed on a horizontal line ends up being the equation, and the same thing holds true for vertical lines. It's the fact that, well, in this case, the x is never going to change. The x value never changes. So it's going to end up being x equals 4 because that value never changed. Let's just look at one more here. We've got this other equation. We've got this vertical line, and we want to know what the rule is. Again, you could throw a bunch of points on here, but like we talked about, we know that the x value, that pattern never changes. So the x in this one is -7, and apparently I went down 3, so it's -7, 3. This one's -7, 0. I didn't go up or down at all, and -7, 6. So what's the rule in this case? What's the rule for vertical lines? Well, just like horizontal lines, where horizontal lines are always the y coordinates, this one's going to be the x coordinate. So the rule is your equation's always going to be x equals whatever the x value is. That's the rule we're looking at. So in this case, the equation of this line is x equals, because it's vertical, and it's -7 in this case. Really quickly, slopes of these type of lines. That can be something that ties into like slope-intercept form and stuff. You know, when they say this, they say M. We'll just think of rise over run. All right, and this can get a little confusing. One of these is going to have a slope of 0, and the other one's going to have no slope, or kind of like the null set. And if we think of rise over run, if you went 2 points here, this thing did run. It ran from -8 all the way to 5. But did it go up or down? And the answer is no. So we have some number in the bottom. We're going to have a number, but the top is 0, and 0 divided by anything ends up equaling 0. If you have a horizontal line, your slope will always be 0. However, a vertical line, that 0 ends up in the denominator because it doesn't run at all. It doesn't go left or right at all. So that causes a problem. If you go to a calculator and do divide by 0, no matter what the number up here is, could be -12, could be +16, it doesn't matter. Anything divided by 0 is not possible. You can't divide by 0. So therefore, this one's kind of like no slope. You could say no slope or sometimes null set. So just think of it, if you have a vertical line, that vertical line has no slope. If you have a horizontal line, that is a slope of 0. And those are two different things. You will get asked about it later. So make sure you're keeping those two straight. Vertical lines, hey, that run, that doesn't have a run, and that's in the denominator. You can't divide by 0. As we move on to other types of equations, it all kind of ties together. So we read this carefully. We say, what is the equation of the horizontal line that passes through the point 6, -4? Well, this is just like before. And if you need help visualizing it, go ahead and throw the point on the graph. So if we go to +6, we go 1, 2, 3, 4, 5, 6 over here, and we go down to -4, and we put our point. And we know we've got to have a horizontal line. Not perfect, I'm going to drop that one down. So if you need, you could plot the points, or you could use the rule. When we said the rule earlier, if you're a horizontal line, that's a y equals equation. So it's whatever the y value is in your original point. That's -4. So in this case, our horizontal line, the equation is y equals -4. And you could test that out if you wanted. You could throw other points down here. No matter where you're at, the y value is always -4. So you're going to apply those types of questions when you're asked if you're passing through the point. Just throw that point on a graph and draw whatever type of line it says. In this case, it said horizontal. Now they're going to throw this at you too, and these are some big words when you deal with perpendicular and parallel. Well, if you have a perpendicular line, technically what that means is it's a line that crosses another line and makes 90-degree angles. Well, if I have a vertical line and I make something that makes an exact 90-degree angle, I can't make a diagonal line. If you know what a right angle is, 90 degrees, you know that these are not 90-degree angles. If you make your thumb and your index finger and you make a big capital L, that's a 90-degree angle. So we need an exact 90-degree angle, which means if you have a vertical line, well then the line that makes it perpendicular would be a horizontal line. So when you have a perpendicular situation, you're going to have the opposite type of equation. If you've got an x equals equation and they say be perpendicular, you're going to need a y equals. So let's think about this. We need the equation of the line that passes through the point 8, 2. So just for visual reference, we're going to go to 8, we're going to go up to positive 2, and I'm going to put a dot. So we've got that equation, and now we're looking at, okay, I need it to be perpendicular to x equals negative 3. So I need the opposite type of equation of x equals. Well, if I need the opposite one, then I need the y. I need the opposite, perpendicular. I'm going to be the opposite type of equation. So this x equals, just as a reminder, this was a vertical line. And we need a y equals. Well, if I'm doing a point, the line that goes through there, and I had a vertical line, then that means I'm going to create a horizontal line. And that means the y value never changes. So y is 2. Let's do one more example, but instead of perpendicular, we have parallel. Parallel means you got the exact same. They're never going to cross. So if I've got a vertical line, I know I'm going to have another vertical line because it never crosses. It's got to be parallel. So again, if you need a visual reference, you can go over and you can say, okay, I'm going to go to point 8, 2, and I'm going to put a dot. And if it's parallel, we've got the exact same type of equation. So when we've got this line, again, if we know vertical lines are x equals equations, maybe you've memorized the rules. Or maybe you still need to throw a couple points on here and see what never changes. So if I'm at 8, 2 here, but I'm at 8, 5 here, and I'm down here at 8, negative 3, I can see that, let's just get rid of that, the x must always equal 8, and that's the equation of the line that's parallel to 8, 2. Hope you enjoyed today's quick video. As always, guys, if you need more support, go ahead and ask your teacher, use the other help videos, and go to that tutoring room. This is Mr. Tukin. Thanks.